do. Walking through the code will tell you exactly how validators are set up. I'm gonna go through each line by line, tell you all about it. And first we'll start with the comments. Look, Max writes good comments, doesn't he? So comments are there in the code to help you. They should be helpful to explain what the script does, how it works, any dependencies, any caveats, how to use it. You got to be careful not to write a book, but also if you don't write enough and you don't have it documented elsewhere, there's different philosophies. Do you want to be self-contained? Do you want it to be paired with another piece of documentation? I may write a blog on this to go into detail to kind of pair with the script as well. But for now, I want to be fairly self-contained to give you enough so you can at least wrap your head around what's happening. So this is a PulseChain Testnet v3 validator setup script, and it was tested on Ubuntu Linux. I'll go tell you more about that as well. But let's see. Yeah, let's go through the description. So description installs the prerequisites: Golang, Rust, Go Pulse, which is the Geth fork, Lighthouse on a fresh, clean Ubuntu Linux OS for getting a v3 validator node set up and running. So I put this in today. This script does not install monitoring metrics packages such as Grafana and Prometheus. So it doesn't do that. Maybe I'll update it later to do that. We'll see. I don't want to complicate it too much, but those are things a lot of people like to have and are good for devs to see what's going on. And I need to go through the process a little bit more myself, but it does not currently do that. So you can call stuff like that out. And then this is kind of for people who aren't familiar with code that much. Basically you just take this script, you put it into a .sh file, a shell file. You chmod executable it to make it executable so you can run it instead of read write. We want it to be executable. And then you can use it. So here's the usage. You /, that means run this thing, the file. And then this is where your Ethereum fee address goes, where you want the fees to go that your validator earns. And this is your server's IP address to do things that the client needs. And the only two specific things that you need to tell the script in order for it to set up things properly. And again, yeah, these are the command line options, basically just what I said. And it elaborates on a little bit more. And then throughout using the script, there's a couple, depending on your OS, and at least you may have to hit enter one time. I could probably automate it, but it's not a big deal for the Rust installation, I believe. And then, so I've been using EC2, the Amazon Cloud Services, to spin up servers whenever I need them. You should be able to use this at home just the same. You just got to make sure on your home firewall to also forward the ports, not just locally. And I did that with my security groups on EC2. And this is kind of just, I explained why you may have to enter through this. So again, I tested this on Ubuntu 2204, and this was with a M2 2x large virtual machine instance, whatever you want to call it. Those are specific to, that tells you, I threw up a chart the other day, but basically it's like, I think 32 gigs of RAM, eight virtual CPUs, stuff like that. Basically the minimum specs in order to have a good time when you're validating. And then use it with a non-root user. So Ubuntu is, if you're using the cloud, Ubuntu is the default user for that. And it needs to have sudo privileges because we use sudo in order to run the script. Pretty basic stuff. So the script does not do everything. There are a couple things you need to do afterwards. I try to call them out. I also try to put them in the script to print on the screen as well. Two basic things to do afterwards. It does everything except it doesn't generate your validator keys with a deposit tool, because you should do that separately on a different machine, generate them separately for hashtag security stuff, and then get them back on the server in order to import them into the client. And then you need to manually do the 32 million TPLS deposit on the launchpad. I could probably automate that as well, but it's going to take a lot more code. So you got to be kidding me. Hopefully this thing is okay. I thought I was going to shut it down for the first time I've used CodeShare free. So I didn't know what was going to happen. So good. It's just a little advert thing. So you could probably automate that as well as calling the API, uploading the file, but just use a web browser. It's fine. Again, don't generate your keys on the server, generate them somewhere else, and then import them back to on your client on the server. These are the commands to do that on another machine. Call them out there. Install Python pip. This is your package manager. Use git clone to pull down the staking deposit client repo. Go in that directory, install the requirements, run the setup, and then /deposit.sh and create a new mnemonic. That is I always misspell that word. There's always, I don't know where to put the M's and N's, and crazy, crazy word. Fun fact, did you know the word facetious is the only word, or not, I wouldn't say the only word, it is a word in the English language that contains all of the vowels, all 5 vowels, in order. Learned that from watching Bad Words movie last night, directed by and starring one of my favorite actors. I forgot his name. What's his name? The guy from Horrible Bosses. Chad, help me out. He was in Ozark as well. Amazing actor. Love that guy. Very underrated movie. Nobody saw that movie. Bad Words. Pretty funny. Anyways, facetious. There you go. And then after you generate the validator keys, you run Lighthouse and you import the keys. And your network is, of course, PulseChain _Testnet V3. After that, so do your validator key generation stuff. The only other thing you need to do is this sets up your beacon and validator clients with Lighthouse. All you need to do after you set it up is import the keys using this command, and then reload reload the daemon, because it's going to generate service files. So I'll show you the service files in a moment, but this is just going to make you do more of a production ready stuff. You can run them via command line, just /lighthouse./geth and all that. But if you want them more in a production quality instead of testing environment, this script does that. It sets up service files that have all the details in it. So this is just going to but you can't enable them and start running stuff until you import the validation keys. So that's why you do this first, and then all the stuff's already created for you, but you just need to enable it and start it once you've imported it. And if you have problems, which inevitably you probably will throughout the process of being a validator, because lots of people run one issue, you got one thing off, something doesn't work. Look at the debug logs, and you can use that either by running on the command line without making a service, or if you already have a service, which is what the script does, you can use a journal control to look at the logs and see if you can figure out what's going on. So let's get into the code. That's just the comments. So hopefully that's framed it for you so we can get into the actual code. This basically just checks for 2 arguments in the script. As we mentioned before, you need your ETH address where the fees are going. You need your IP address, which is what Lighthouse needs for validator stuff, the way it's set up. Well, you'll see it when we get down to command line args. So if you don't, it says try again. Once you have entered those 2 things, these are just some of the variables. So it'll assign fee recipient and server IP address to the first and second arg respectively, as we see here. It will create a node user, which we'll see the command a little bit later on. This is the name. It could be anything. It could be Blazing Glory if you want. I just call it node because that seems appropriate. And then your app packages. These are the ones I figured out, which are the minimum for what you need to get everything working. And then key difference here. Geth chain is PulseChain -Testnet V3 -Testnet -V3 uses dashes. Geth uses dashes. Don't get mixed up on this, because I think I messed it up before and caused me some time trying to figure it out. Like, oh, what's going on? And it's such a simple little thing. And then Lighthouse uses underscores. So Lighthouse is PulseChain _Testnet _V3. Very subtle but important difference. The Geth config, this is just basically we're putting in the op directory and we're using that, and JWT directory is there. That'll be this for the secret we generate so the clients can talk to each other. And then the Geth repo is the Go Pulse repo at the PulseChain.com. family of repos. I forget what that's called. Is that like an org? Yeah, PulseChain org. GitLab, GitHub, different things call them different things. And then your Lighthouse directory. You use opt Lighthouse, all different stuff for that. And actually, I don't think we use password file. I could probably remove this. I don't think Lighthouse uses password file. I think that was left over from Prism. So should make a note to remove that. That's it's a good call for me as well. Let's see. I like this. It's like I'm doing a code review with you all and myself. Again, if you have any questions, feel free to throw them in the chat. What's up, Valley Brand? Good to see you, man. And then we have, this is the repo for Lighthouse-Pulse. So that is the one for that, just like Geth. Repo name, just so I can reuse it later. And Lighthouse port 9000. And then checkpoint you're up. So why do I have these things? Why don't I just put them all in the code? Because if you make them variables, they can vary. I know, mind blowing, right? You can change them easily. And if you use them more than once, the general thumb, if you use a static value more than once, then you can just change it to whatever you want. So I have package. If I just paste this and I use this like 5 times, which I don't, but if I did, it would be very hard to go back and change it, the whole thing 5 times. Why not just make it a variable? And if I want to change it, it changes all the times I use it in code. That's why I use variables. It just makes the maintenance and using the code and changes and stuff like that, it makes it easier and easier for people to figure out what's going on because you're defining everything beforehand that you can. Now you can do overboard, you can variabilize everything. Not really necessary, but that's why I chose to do it. Just a little bit of thing that makes it easier to, stop the script if I need to without getting messy. And then I'm just echoing some stuff. This is stuff printed on your screen. Validator setup, helper script. Again, some steps need to be completed manually. See the notes. I'll talk about this more at the end of the script. And it takes about 30 minutes. I timed it. And on the M2 2X large, the instance I was telling you about that I tested it on, it took around, I want to say 30 to 40 minutes. Could be quicker depending on your bandwidth, could be slower, could take 2 hours, could take 15 minutes depending on the specs of your server, but this is what I tested it with, so that's what I felt comfortable writing there. And then read P just says, send it, put a message here, and you got to hit enter to continue, just so you have time to read what this is saying before the script continues and your terminal is full of stuff. So let's get into it. We're almost in the code. I mean, we're in the code, but not the juicy parts yet. This is just a trick that just to keep track of the directory. Nothing important to explain at least. And then again, each step I echo, hey, here's what's going on, install the requirements, setting up Golang and Rust. I do apt-get update. I automatically install all the app packages. I install Go via Snap, which not important. Why I use Snap instead of apt for the packages. Actually, this could be apt2 instead of apt-get, but it doesn't really matter. And then this is straight up from the Rust website. This is how they tell you to install it. So super easy, just copy and paste that command. And then you source this to make sure you have it in your environment so stuff executes correctly. Then step 2, let's add the node user and generate the client secrets. So this is where we're going to add that user called node to the server. And yeah, none of this, let me know if you want me explaining any of this stuff, but it's not super important. You're just adding a node server there. You're giving it no shell by default, and you're making sure to create a home directory. Yeah, I'm not going to explain every single option, but I'll just, at my leisure, I will talk about them. And then create the JDB secret. This is the stuff the client needs to securely communicate. Don't really need to understand much more beyond that. Lock the secret down. And then step 3, actually install GoPulse. So this is their execution client, Geth. We start syncing the data. We clone the repo. Funny enough, this kept failing. I was like, why does it keep failing? Like, does it literally, because Git is kind of a funny command. It's pulling down code and stuff. And if you run a command after it really quickly and it's not finished, some background process isn't finished, something like that, then it'll actually fail sometimes. So it's so funny. I was like, all right, I'll just sleep for a half a second. It's to make sure you don't fail. So yeah, this is why you test things 100 times to make sure they work. You don't just, or I try not to just write commands out and just hope they work. I try to vigorously test my stuff, and it still, I'm sure, will break in some environments, but yeah, this is within reason. I try to make sure everything runs smoothly. Go to that directory, make. So this is where you start building the code. This starts building the Go Pulse directory. And then we add the geth binary to our path, just so we don't need to type in the full path. We can just type in geth and it works, because that's how that works. And then make directory P. This means ignore it if it's already there, I believe. So I put that there. And then this is just setting some permissions, nothing fancy. Now we're getting into creating the service. So before I said you can just run it on the command line. Run, if you go to Gamma DevOps, he's got all the commands and stuff right there. I'm sure I'll put some on the blog, and in the docs I've shared before, there's just commands there for you to run the stuff. That works totally fine when you're testing. But if you're in production, if you're in prod, for example, you want to be able to control this. After you've tested it, you make sure it works. You want to be able to control this in a way that's like, start the service, stop the service, tell me the status of the service, give me logs for the service. You don't want to have a terminal open all the time for everything and doing all kinds of stuff around that. This just makes a cleaner deployment of these clients, putting them in a service type atmosphere. So we just name it, tell it dependencies. We tell it what user to run it as. Another benefit of using a service, makes all that stuff easy. Just not very important. And then the actual arguments that go to it. So this is telling it use geth, use the chain, the PulseChain Testnet v3, and the variables that we talked about before. Tells it the data directory, use HTTP, turns on these different engines and features and stuff. And then use the JWT secret at this location. And then just basically enables the service and tells it to start up, because we can start geth. We can't start the Lighthouse client yet because we haven't imported the validator keys, because after we run the script, we have to import the validator keys. If you remember what I talked about in the beginning, I'll throw it back to you at the end as well, because that's what I talk about too. So we got geth set up. Awesome. And the reason I'm talking through this too is, again, you can do all this stuff manually. You don't have to use this script. This is telling you like step-by-step how to set up a validator manually, but I just put it all nicely into code. So you can just run a script and it does it for you. But this is for you to learn how to do it manually as well. So let's get to step 4. Let's set up Lighthouse. That is our beacon and consensus client. There's 2 pieces to that. You'll see down here when we get into the commands. And again, you need to start and enable it manually after generating and importing the validator keys. So with Lighthouse, pretty similar. We clone it, we wait, and then we move it around, and then we build it. And that's probably the longest part of the setup. I think it may take 5, 10, 15 minutes to actually build it, because it's got to pull down a lot of stuff, build some code. Geth is pretty quick if I remember. And then we just create some directories. And then, this is like just a little trick I had to do just to work around some stuff. So I create a symbolic link to the actual binary. Ooh, I need to make that. See, this should be the variable. This should be that. So make myself another little note. Change static home user to, in the grand scheme of things, I mean, it does not matter at all, but I'm just, if you're going to do something, do it. Don't take a lot of short. Have to. These are just simple little stuff you can fix in a minute, just to make it cleaner and everything consistent. What line is that? On line 223. Again, Max is not really a dev. I mean, again, I'm a dev by this community standards, I guess. Not saying you guys have bad standards or anything, but I guess if you think dev is anyone who can write code, then yes. But, in the professional and the tech world and stuff, I could, I would not be nobody would hire me to be a dev. I mean, not nobody, but all the big companies wouldn't hire me to be a developer, because, I have security skills and stuff. But I do write code. So if you want to call me a dev, it's funny. It's just 2 different worlds. It's that I entertain here. Anyways, make a symbolic link to hit up our actual binary with here. So you can execute this, it will actually execute that. And I just thought that was neater than putting this in here. It's actually not even really needed, but again, I try to go for cleanliness and readability and stuff like that as your dev max. And then we do network, again, the chain we talked about earlier, the data directory, the execution endpoint. I mean, a lot of stuff you don't really need to understand that much. Where a secret is, this is your IP address that you entered in the beginning. This is your fee address. It's your ETH address that you gave as a command line argument, if you remember in the beginning. The different ports we use for Lighthouse, the checkpoint URL to help sync stuff faster, and then enable HTTP. So we do everything we did for Geth and we enable it, but we don't start it yet, again, because we need to import the validator keys before we start it. And I'll go through the script and I'll look at chat and I can scroll back through it, but just let me get through all of this and I will circle back. And so that was the beacon part. Yeah, I said I was going to highlight that beacon node or beacon network, whatever it stands for. And then this is the validator part, validator client, I assume that stands for. So again, you need both of these running. And then same thing pretty much. I mean, this has a couple commands, where your fees go, what chain you want to use. And then again, here you enable it and you don't start it yet. And this is just some stuff to make sure Lighthouse has the rest environment, just kind of a couple workarounds I had to do. Nothing really notable. And the last step is setting up a firewall. So it's most important to do this. I mean, by default, depending on your OS and stuff, it may not be necessary, may not, as far as locally doing this. Depends on your firewall default settings. But you definitely need to do it on your network firewall, if nothing else. If it's not necessary on your server, it's at least necessary for you to open up on your firewall to make sure that the validators can talk to each other and all that good stuff. And at the end, almost done. Again, this doesn't do 100%. This does 85% of what you need to do once you have your hardware and stuff set up. So you still need to generate your keys on a different machine, import them into Lighthouse. I give you the command to do it right here, as well as in the comments above, I believe. Then make your deposit at the launchpad at this URL. And then start your beacon and validator clients, your Lighthouse clients. And hopefully you don't run into any errors. Hopefully you start syncing. Hopefully there's no other bugs or anything. But if there are, you can debug it with the journal control, as I mentioned in the comments above as well. And this is for me. Verify all these steps here. I pretty much have verified that. So I guess I can remove that in the script as well as some of the other stuff I commented out just for testing. Because if you delete it, if you delete it, then you don't have it anymore unless you copy it to another file. But if you comment it out, you can always go back if the new thing you did doesn't work, or you could just kind of use it as a reference to like the next thing you should do. Different ways of using comments.